In this video, we'll do an example of an infinity minus infinity limit form with L'Hopital's rule. So we have the limit as x approaches 1 of 1 over ln of x minus 1 over x minus 1. I want to first give you 3 minutes to try this on your own. So 4, 3, 2, 1, pause it for 3 minutes to try it. All right, let's go ahead and talk about it together. So as a first step, if I plug in 1, I would get 1 over 0 minus 1 over 0. And it might be tempting to say, wait, 1 over 0 minus 1 over 0, isn't that just 0 because they just cancel out? But we got to be careful. With undefined things, we can't just do arithmetic in a normal sort of way. I can't just say that these are the same. In fact, when I write 0 on the bottom, technically it just means the denominators are getting really, really close to 0. But the denominators may be getting close to 0 at different rates. So these 1 over 0s may have different sizes. And 1 over 0, because the denominator is actually getting really close to 0, this is some type of infinite thing, either positive or negative infinity. And then minus the second 1 over 0 type thing is also some type of infinite thing. And an infinite minus an infinite thing is indeterminate. This is indeterminate. Okay, so it's like I have my indeterminate form, infinity minus infinity. That's not a form I can use L'Hopital's on, at least not right away. So I have a fraction minus a fraction, and one strategy I can use to simplify this is to get a common denominator. So we can get a common denominator. So if we did that, we would have the limit as x approaches 1. And I would multiply this first fraction on the top and the bottom by x minus 1. So I got x minus 1. That'll make the denominator be x minus 1 times ln of x. I'll multiply the second fraction on the top and the bottom by ln of x. So when I combine the fractions, I'll get minus ln of x from the second fraction. That's the numerator of that second fraction. All right, so now I have one whole fraction like this. If I plug into this now, if I plug 1 into this, on the numerator, I'll get 1 minus 1 minus ln of 0, which is, ln of 1, which is 0. On the bottom, I'll have 1 minus 1, which is 0, times ln of 1, which is also 0. So we get 0 over 0. Now, this is a form I can do L'Hopital's on. Okay, so it wasn't something I could do L'Hopital's on at the start, because it was infinity minus infinity. It was a different type of indeterminate form. But I simplified it to this fractional form where I could do L'Hopital's on it. So I'm going to write LH. I'm about to do L'Hopital's at the step. We'll get the limit as x approaches 1. So the derivative of x is 1. Derivative of 1 is 0. And then minus the derivative ln of x, that's 1 over x. On the bottom, we'll need product rule. So I'll get the first function, x minus 1 times the derivative of the second, which is 1 over x, plus the second function, ln of x, times the derivative of x minus 1, that first function, which is 1. Okay, and now let's simplify a little bit. We get the limit as x approaches 1 of 1 minus 1 over x over, let's distribute 1 over x to these two terms. So 1 over x times x is 1, and then times the negative 1 is minus 1 over x. And then plus ln of x times 1 is just ln of x. So let's try plugging in now. If I plug in 1 now, I'll get 1 minus 1 on the top, which is 0. On the bottom, I'll get 1 minus 1, which is 0, plus ln of 1, which is 0. So 0 is still on the bottom. So maybe we try L'Hopital's again. Let's try L'Hopital again, and we'll get the limit as x approaches 1. And then the derivative of 1 is going to be 0. The derivative of negative 1 over x is going to be 1 over x squared. So I kind of did that quickly in my head a little bit, because I'm just using the fact that negative 1 over x is negative x to the negative 1. And then when I do power rule, the derivative will be 1 over x squared. Okay, and on the bottom, the derivative of this negative 1 over x is also 1 over x squared. And then plus this ln of x, that derivative is 1 over x. And now I am good to plug in. There won't be issues. If I plug 1 in, I'll get 1 on the top over 1 plus 1 on the bottom, which is 1/2. And that is our answer.